Hello, and welcome to this Automation World webinar sponsored by Schneider Electric. This webinar is focused on a real-world case study of how Ascend Performance Materials use software to improve its manufacturing quality. I'm David Greenfield, Director of Content for Automation World, and in this webinar I'll be speaking with Terry Unruh, Production and Maintenance Process Leader at Ascend Performance Materials, about how the company used software to improve product quality, optimize manufacturing operations, avoid downtime, reduce maintenance, and lower its utilities costs. Also joining me is Hoffman of Schneider Electric to explain more about the specific software technologies used in this project. Now at the end of this webinar we will have a question and answer session, so stay tuned for that. And please note that you don't have to wait until the end of the webinar to ask your questions. You can enter them at any time during the event via the webcast interface. So Terry, let's get started by telling us more about Ascend. What products do you manufacture? Where are they used? What can you tell us about that?
Sure, David, thank you. Ascend, we make a Nylon 6/6, and it's made in about 5 different plants in this country. It serves the worldwide audience. As you see on the slide, we've been doing this about 60 years plus. And you probably don't know what Ascend Performance Materials is, but essentially, if you go back a number of years, we were part of Monsanto. And back in the 90s, Monsanto spun off a division called Solutia, and Solutia sold the fibers part to SK Capital. So we are essentially the Monsanto fibers division. We're a large-scale producer, probably the largest in the world, fully integrated in the Nylon 6/6 resin. We hope to be the world's most reliable, innovative, and responsible producer of Nylon 6/6. And if we go to the next slide, some of the products we make you're very familiar with. You may not recognize, but Nylon 6/6 it's a polymer that's very heat resistant, stable, and such. In automotive applications, it's used in things like air intake manifolds, engine covers, the end caps on radiators, emission canisters, various different things. You're all familiar with carpet, of course. I think ours is Ultra Nylon, used to be the wear-dated material. Industrial fibers, we probably make most of the fibers that go into airbags in automobiles. And also fibers into things like parachutes and such. One of the items that you typically use a lot of, the cable ties in industry, we make most of those. They're out of Nylon 6/6 also. Let's go to the next slide, please. And this kind of gives you a graphic. We're in the southeast. Main plant, our plants are Chocolate Bayou, Texas, near Houston. We have a small plant in Foley, Alabama, a large plant, Pensacola, Florida, also Greenwood, South Carolina, and Decatur, Alabama, headquartering in Houston, Texas. Those are the assets that we currently have. Okay, next please.
Okay, well thanks for that background there, Terry. So Ascend recently completed a project called Visual Factory. What can you tell us about this?
Yeah, on the Visual Factory, it's a project that's, I'd say it's really still in progress. We've completed parts of it in various of our plants in Pensacola, Decatur, Greenwood, Chocolate Bayou, and some of the units. We have 6 to 8 installed currently, and we're moving to get the whole company on essentially that system. It encompasses IntelaTrac, which is the mobile data acquisition, field data acquisition that Schneider has, including some of the other Wonderware products, the intelligence, the workflow, and such. And as you see from the slide, that's our intermediates plant manager at Pensacola, John Johanneman, and he essentially says it's the big picture. In fact, he really likes it. He likes to see that on his desktop. It's essentially, we're looking at dashboards and such, and he can glance at that and basically tell if we're running well or if we're getting a little bit close to where we shouldn't be running, as he said, going to ditch. And and able to see where we are. I will make one comment here that this is not DCS. This is not distributed control or such. This is not what keeps us running safely. We're using Visual Factory, which is near real time, to operate efficiently. Now, let us know when we're not operating efficiently, and that's our goal here. Not to take over what DCS would do, not to control our safety and those type limits, but this is for efficiency improvements.
Okay, so Terry, tell me more about what led to this. What were the challenges that Ascend faced that prompted you to develop Visual Factory?
I think Ascend, as we were trying to progress with continuous improvement, that was one thing that owners really like to do is have us really improve and get on that mindset of improvement. Some of the challenges, some of the units, some of the KPIs were in various different places. Some people had them on spreadsheets, some had them on maybe whiteboards, various different places. Some units really didn't have a lot of KPIs. So it gave us a really good opportunity to understand what are the key KPIs, key performance indicators, that the unit should be looking at to run efficiently. Also, it would take a lot of time to gather together the data and understand what really was going on. And for instance, between shifts, the night shift made understand what the KPI is. The day shift, well, you got the engineers and supervisors coming in and to help them understand it. On weekends, there's no one around to really guide the operators. So a lot of time at night and weekends and such that perhaps the unit was not running as efficiently as it could. But if the operators had some knowledge, some information, a tool to show them that the system was say, going towards the ditch, as John mentioned, then they could take some corrective actions. Also a good way to make sure that the shifts had some accountability one to another. And we would aggregate some of the data together to understand what really was going on. So again, we tried to make something that was from inconsistency to consistency. As someone wrote, from a lot of visual management, you go from informal and frequent and some fragmented informations to something that's updated, visualized, and everyone knows the objective, status, and the performance of the system.
Okay, so if those were the challenges you faced that led to Visual Factories, what were the principal objectives of the Visual Factory project?
So for the project, we wanted a real-time dashboard. We wanted something where not just operators, engineers, managers could glance at the system, say in just a very brief amount of time, and determine, are we doing well or not? It's something that, as someone said, sometimes operators don't know how we win. And that's real important. Operators need to know, are we doing well? They want that feedback. And the dashboarding, the visualization will help them understand how we all win together. On the next slide, with the, there we go, alerts and troubleshooting, we wanted to have the dashboards to actually allow the operators to understand what to do. Not just there's a problem, but allow them to drill down and understand where the inefficiencies were. So we tried to gather together in one place operator logs, operating procedures, troubleshooting procedures, documents, trending from historical data, and we call it like a one-stop shop for troubleshooting. So if we find that, say, energy is higher than expected, then they could drill down in the dashboarding, drill down to different screens to find out, well, is it a column, is it reflexes, is too high, somebody left a steam jet on, something like that. So they can try to incorporate that right there on one system versus having to go to one computer to look at the data store in, another computer to open up SharePoint to get Word documents for troubleshooting. Here they have it all in one place, and it makes it easier for them to actually do what they want to do. So we try to standardize and consolidate. You can imagine that various operators had different ways of working. We went to one unit and someone said, well, I like to look at this trend, and someone else said, well, I like this trend. And so we tried to combine all those into the visual factory where the system would look at the trends mathematically and say, okay, is this going the right direction or not? Is this outside the boundaries? Is this going up too fast, going up too slow? Is it rising when it should be falling? Those things will be alerted to the operators versus having to look at a trend or perhaps not even see the trend that someone else will be looking at. So in essence, we were trying to get the best knowledge of the group into one place that all could look at it, all could see that information. So we take information from data historians, LIMS, SAP, IntelaTrac, and combine all that where they can see the data and make good decisions based upon it.
Okay. Thanks, Terry. So we've covered the challenge you faced that led to Visual Factory and what your principal objectives for the project were. Can you tell us now about the key benefits that Ascend has received from implementing Visual Factory?
In Visual Factory, again, I'll encompass Visual Factory and IntelaTrac all kind of somewhat together. But we now see in real time with looking at the data, again, data from production systems, from LIMS, or quality systems and such, that all this data is coming in, and what do we do with it? And if you're familiar, normal DCS systems could have 1,000 data points, and we certainly can't ask an operator to go through all his screens and look at all the data points to make sure we're running efficiently. Now, of course, the DCS is looking at to make sure we really stay out of the bottom of the ditch. We don't want to go there with something that's out of safe limits. But here with the Visual Factory and dashboards, we are allowing them to see the process, see when they're starting to get out towards that edge. So they can review that. They visibly see the KPIs, the performance indicators, and they understand they can actually take some action to make sure we're in the correct range. So we try to integrate the different data sources. We tried to use best practice. We'll go from, say, one implementation and a pilot to another, and we'll learn, take those learnings with us, and we'll keep improving this whole dashboarding system as we go. So mentioned on the slide, we could have alerts. We could have pop-up windows that can alert the operator to something that's going in the wrong direction. You can take some action. The system can send emails, reports, and notify engineers or supervisors of things going on. So it makes it a very accountable culture when everyone can see what's going on. Back in the Six Sigma world, they used to say that it was MBWA. It was management by walking around. And here we're looking at management by seeing what's really going on and asking questions. I had a supervisor, unit leader that had a pilot of this system. And of that pilot, they actually would go through and look at it, and they would call the operators and say, what's going on here? Why is the energy out of control? Why are we going to have operators? Well, what's going on? They didn't even know what was going on. But by seeing the dashboard, the unit leader could encourage them by, quote, walking around or calling around to say, what are we doing? So he would encourage them to get the accountability and the culture that that was very important. And the operators could understand, based on what they could see, where their level of ownership and accountability was. We did try to stress to folks as we came up with the Visual Factory, came up with models and such. So we tried to put some things in dollars and cents, so they could actually tell where they're operating, their impact on the business, whether energy was in balance or not, or yields, it's worth $10,000, $100,000, whatever it was. They could see their impact on that. One of the folks, engineers, said, his quote was that we're now operating better in control. That we're looking at issues faster, resolving them faster, and we can operate more in target, essentially reducing variability as the Six Sigma thing. We will reduce that variability and be able to operate on the target we want. It's interesting that we look at the people efficiency on there. One of the things that one of the operators said, a very interesting comment, that once we got the visual factory going in one of the units, he said, well, it's amazing because the control room's quieter. Yeah, less Provox alarms, less DCS alarms, because they're now operating closer to where they need to be towards target, and that keeps them away from some of the DCS limits. So they actually were operating more efficiently, and they could tell that just by the level of noise in the control room. One of the things that we first started this, operators really wanted was a searchable logbook. And in this company, we had the standard paper logbooks. So one would, if someone had a problem with 51 P29, a pump, when's the last time we had that problem? At least an operational problem, not something in the maintenance records, but operational problem. They'd have to page back in their logbook, page after page, get another logbook month after month to try to find that. So they said, we really want something we can electronically type into. So with the searchable logbook, they can just search for a pump, search for an incident, search for something, and find that very quickly. It's something that's extremely helpful for them. And we found in most of the units, and they actually categorized this and found that we actually were getting 15+% more input in the electronic logbook than we were in the paper logbook. We made it easier for people to put something in the logbook than in the paper.
All right. Well, thank you, Terry. Thanks for that. Yeah, thanks for that detailed response there. Thanks for that, Terry. We're going to move over to Derek Hoffman with Schneider Electric here now for a bit. So, Derek, can you tell us about the main Wonderware products that were used in the creation of Visual Factory?
Sure thing. Thanks, Dave. Yeah, the Visual Factory solution was developed with the idea that the Ascend manufacturing stakeholders needed one place to go to get a comprehensive view of what was happening in their area of focus. As Terry stated previously, they had a limited or partial view of how the business was performing. So what we did is we have a great team of professional services folks who work closely with Terry and his team to map out a solution that would provide the right level of visibility and context so they could make better decisions and ultimately drive the enterprise. So we utilized Wonderware Intelligence for the dashboards that operators and supervisors interact with. Skelta BPM was used to create an electronic logbook and shift instructions repository that Terry was just talking about. For reporting, we also use intelligence, and it's fed by many different data sources within the SEND, so IntelaTrac, LIMS, and SAP being a couple of those. And then events are managed by Skelta as well to provide notification and alerts as needed, and those are based on particular workflows that the team has put together. And by the way, I have to give Terry credit for a great name. We think Visual Factory is a great project name.
I see from your slide there, Derek, I see that Wonderware Intelligence played a key role in a few facets of the project. What was it used to address?
Sure. So Wonderware Intelligence software addresses the challenges that are faced by Ascend and many of our customers today who have a lot of data out there, and they're looking to uncover those hidden insights. The software automates the transformation of time series and transactional data from many different data sources and turns that data and information into actual metrics and KPIs. What we do there is the metrics and context is provided in an open information model, providing a single version of that truth and of the current data. So we use intelligence to pull and extract that information and store that information from the data sources for the Ascend enterprise. We put that in a common data model, and that supports the various dashboards and reports that the Ascend user community requires.
Okay, thanks. And I see that Skelta BPM was also used a few times in Visual Factory. Tell us a little bit more about that.
Yeah, that's right. So this is a screenshot from the Skelta product, our workflow tool. So Skelta BPM is our workflow application that Ascend is using to create their e-logbook and manage alerts and notifications. So Skelta is a very configurable, robust workflow tool. It's a perfect fit for these types of requirements. Using Skelta, we created the forms that are what the operators interact with. That's what the e-logbook is. They can quickly enter information into those forms. It's captured into a repository that's searchable and traceable. And then we have workflows that are ready to go that are event-based and fire off alerts and notifications when it's appropriate.
All right. Well, thank you, Derek. All right, so we're going to move back to Terry now. Let's talk about how data accessibility was a key to the success of this project with the Ascend field workforce. What were the advantages of using IntelaTrac for this aspect of the project?
IntelaTrac was just a key basic function to allow us to gather information that had never really been gathered. From us, perhaps other companies, our culture was essentially we capture field data. The operators would do rounds, they capture the data on paper. That paper would go into a file cabinet and collect dust and be brought out in case there was some kind of a root cause analysis. But here, we actually have, with the IntelaTrac there, we manage the data from in the field. We actually capture the data. We can trend it. We can set limits. In the IntelaTrac with the mobile device, we can have the first level of troubleshooting. Essentially, if a pressure is too low, pressure is too high, it can flag that and actually ask the operator to look at something else. It can look at that first level that someone with the knowledge would want to do. We were very careful. We did not want to program paper to plastic, as we would say. We tried to program with the IntelaTrac all the things operators should do, even though it may not be written on paper, but all those should do things that they should be looking at. And we've been very successful at doing that, and we found lots of different items, and if there's time remaining, we'd go through a couple of the stories, but a lot of things were not written down that we asked operators to capture, and it worked out very well for us.
Okay, so let's dig a little deeper into the software from the user point of view, Terry. Can you tell us more about the various components of Visual Factory?
Well, the Visual Factory, we've talked about dashboards. I mean, dashboards with, we typically have a safety component with quality, production, reliability, OEE, energy, yield, and such. We get the data from the different sources, whether it's from SAP, LIMS, our historian, SAP, things like that. We bring all together and display that. With the dashboard, we essentially had different levels. We had a main dashboard with some of the overall KPIs, some of the gross items, the 10,000-foot level. And with that dashboard, we could tell it was something red or something green. We'd use the colors to designate we're okay, we're not okay. If something was red, we could essentially drill down to the next level. We call that level 2 dashboard. And that we'd have more detailed information, detailed variables and such, and with trends, graphs, and such. And this is role-based, where we could actually make sure that folks that did not have the authorization to look at data were not allowed to do that. So we controlled that. And as I said before, we have tighter control over targets. We actually model our targets so that they're appropriate for the conditions the unit's operating. On the main dashboard, you can see the different sections up there, and those, again, that would be something like safety, environmental, production, yield, energy, and such. We used graphs, trend lines. In the different sections, we would have the headers turned either green or red. We click on those, or click on an individual one of those lights that was red, and actually drill down to the next level. It provided something very meaningful for us. All the other dashboards, we have links either underneath or a sidebar. On the top, we'd have things like daily instructions. That was another part of it that we'll get to, plus operating documents and electronic logbook, that we could click on those. So on the Logbook, we've talked about that a lot. That was very beneficial for us, and we'll show a little schematic of that in a minute here. Shift instructions, we tried to have something that was very valuable. You know, the units and operators would receive their instructions. Sometimes they'd lose them. On paper, they lose them. They'd call the person on call and say, what target am I supposed to be running at? Here with the shift instructions, the engineer or the specialist would fill in essentially a format. This is from the workflow. They'd fill it in with the targets, if such, the levels, the maintenance instructions, all those things that group needed to have that night or that weekend. And if it was a target or something, that would be sucked right into the visual factory where it would show green or red. So those targets would automatically be sucked in, no question about where they should be running. So on the next slide, I think there's an example of the e-logbook. E-logbook, we tried to make it so it was very clear, very easy to use. Operators had a problem with a pump, we would give them a selection of pumps. They wouldn't have to type it in. They could just click on a box. So I have a problem with 51P27. Click. And they would give them a list of typical problems. Is it a seal problem, a flow problem, something like that, and they could click on that. So we tried to make it fairly easy to actually put something in. Plus, they could actually freehand write notes, attach pictures, drawings, or whatever. So it made it fairly easy for them to put in an event. On the next slide, with the shift instructions, again, same kind of thing, a format where we could just, they would have the previous shift instructions from the previous day. They could go and just kind of overwrite, edit, and make it very easy for the engineer or the specialist to do that. And then one thing that's not shown here that we did a lot of units, we'd have something that the unit would have to click on. The unit, the board operator, or all the processors, depending on how it was programmed, they would acknowledge reading those instructions. So that created some accountability that on the very main dashboard where it said daily instructions, that would be read until that board person had actually clicked on that and read those instructions.
Okay. Well, thanks for explaining all that, Terry. That was very in-depth, so thank you for that. So I guess to wrap things up, what would you say were the main business metrics obtained from using Visual Factory?
I think from the Visual Factory, and I'll include IntelaTrac in there, with all that software, we had some really good benefits. We've actually got the operators to understand that they could save time. They run more efficiently. And as you said, we said before, we could run with a quieter control room, which had some very unintended consequences, which were good. So we saved, say, $500,000 in utilities and material costs. And again, a lot of this was with the different software programs. Again, we had energy and steam traps. A company like ours, I don't think we have 13,000 steam traps or something. We actually come up with a creative way of taking IntelaTrac, and that is we go in the field and survey steam traps. And you can imagine with 13,000 of them, that's a lot of surveys. So in the past, we'd have a contractor come in, they would do part, and they'd do another part, and we'd get a report, and eventually it would get to somebody, and they'd look at it and say, okay, here's 15% of these traps are bad. How do you prioritize? How does one know which ones to work on? So we took the steam trap routes, and we took the steam trap data, and we actually took the intelligence. We put all this together, so in the field they could run the IntelaTrac round. That would create a list of, or at least the database of the steam trap issues, whether it was blowing through or cold plugged or something else. And that would go to a database that would match up that trap and that characteristics, orifice size, steam pressure, and such. And that would go into the intelligence, and we'd have a nice report saying, okay, here's the steam traps that have failed. Here's the time, say the mean time between failures. Here's the dollars it's costing us. So we could easily prioritize, well, here's the traps we need to work on because it's costing us $30,000 a year or $40,000 for these traps. The other traps may be $1,000 or $2,000. So we could prioritize using all the software together where to work on, what to work on. And I think that our energy manager is saying that we're probably going to save $1.5 million based on all this work. And we've also extended this now into leak surveys, installation surveys, and others. We can combine all this together to use these pieces of software. I think that's a really good way that we've tried to use this. Shutdowns, we save several shutdowns just because we put standard work in our IntelaTrac system. And we would look for spare pumps. We would make sure that the equipment was operated properly. We found things that we were surprised at. We found motors that wouldn't start when they should have started. And if they had not worked, we would have been shut down. We found other pieces of equipment that were near failure. And we found those before they failed based on the IntelaTrac. Overall, the technology, the last bullet here, this refers to mainly the IntelaTrac, our very first part of getting into the software from Schneider. And we actually went from, zero to, we call it the HERO project, Handhelds for Excellence in Reliable Operations, 0 to hero in 90 days. We went from nothing, and then having the Schneider support and producing the rounds for our utilities plant in Pensacola, a very large number of rounds and outside processors. We did that essentially in 90 days. So it was a very good success. Operators saw that, and it was very encouraging. And it lent us to moving on with that project throughout the whole company.
All right. Well, thank you, Terry. So we've been getting quite a few questions here during the webinar, so we're going to go ahead and move on to the Q&A portion of the presentation. So if you're out there listening and you haven't already entered your questions for Terry or Derek, now is the time to do so. Go ahead and enter them into the webcast interface, and we'll get to them in the mix here. But let's start off with some of them we've got here already. One of these is a question for Terry here, and it's asking to explain a little bit more about how extensive your data collection and reporting is with Visual Factory. I know you've hit on a good bit in the presentation, but how extensive is it? Is it from a lot of different sources or a few key ones? Can you explain that a little more?
For the Visual Factory, our data collection, I would say primarily is from our data historian. I mean, that's probably where it's from, and we report out from there. Now, with the IntelaTrac, we're getting a lot of field data that we've never got before. We're getting pressures, temperatures, we can build trends, we look for problems based on that data that no one really has looked at before. And that's being brought into the Visual Factory. For instance, we can look at, with the Visual Factory, we can look at a flow rate. We can look at a valve position. We can look at the ratio of the flow rate to valve position and try to determine if we're plugging. And that can give us a plugging indication before it happens. If we start seeing the ratio go in the wrong direction, we can send an alert to the operator and say, yeah, maybe we'll go out and look at this. Maybe something plugging up that we can go out there and flush through and back flush or something and make sure we don't run into that problem of having a shutdown situation. So I think that we do have data, we have reporting, we do report with IntelaTrac, we have web reporting that goes out to supervisors, we know which rounds might be missed, we know which equipment has alerts on it. With the Visual Factory, we have some reports that go to supervisors, and of course the main thing is it's right there on the web. It's all web-based, and it's right there for anyone to log in. It has permissions, of course, to see, and that's going back to the quote from John Johanneman. He likes that. He really liked that. He wants all of his units to essentially have a Visual Factory system, and most of his do now, and then we'll eventually build him his own dashboard, per se, that combines those, and then he can see, unit A, B, or C, are they green, red, or whatever, and that's something that would be very easy for him to try to track and manage. Again, that's the old management by looking around.
Okay. And we got another question here. It's asking about the E-log book data that you were just referencing. It's asking exactly where this data is stored. Did that come from out of the box? Is there an out-of-box viewer for that, or was that something you created with Visual Factory?
That was programming that Schneider did for us using the workflow. Derek can probably elaborate more on that, but that's what the workflow, and we try to design that so that the operators could do more click and point versus typing. You know, a lot of operators don't like to type so much, but giving them an opportunity just to go click on what's the event. We have a leak, we have a pump issue, an exchanger issue, and then if based on that question, you have a list of, okay, it's this exchanger, that exchanger, and then what is the problem. So we try to have kind of the treed approach where they could easily get to a solution or get to an input without having to type a lot. And then they could also, you know, certainly type in the notes. And it's amazing, some of the older folks have really caught on to this, even though you might think that they're maybe technology challenged, but they're not. They actually really do like to get in and comment. And as I said earlier, we're receiving more input from operators now than we did on paper.
Derek, do you have anything to add to that?
Yeah, so I think Terry summarized that well. You know, those are forms, those are the front end were created with our skeletal workflow solution, and then on the back end we have a database repository where the information resides, and that's searchable and very easy to access as needed for the different users at Ascend.
Okay. So this next question could be both for Terry and Derek. I guess for Terry from Ascend's point of view, and Derek from, you know, working with several customers, I guess, across this. But it's asking about what are the advantages of having operational KPIs of the type that Ascend created with this visual factory. I guess we'll start with you, Terry. Can you speak to the personal advantages you got from that, and then I guess we'll move over to Derek for some general comments on that.
I think the advantage of having KPIs that are visible is understanding, like I said, the point of how do we win? What's winning? You know, if I'm an operator, and you know the traditional way of operating is, okay, I have my logbook, I have some instructions, I have my DCS system, and I'm keeping the alarms out. I mean, that's kind of the typical way that people used to operate. They keep the alarms out, make sure, you know, your things are relatively on target, but as long as there's no alarms, it's not that bad. But with the visual factory, we can now narrow in on that and make sure that we're operating efficiently. And as someone said, it's like bowling. The DCS system can keep you out of the gutters. It to make sure that you don't go in the gutter and do something bad. But the visual factory, we're trying to hit the pocket and actually maybe get a strike. So we're trying to hone in on that and operate efficiently.
Yeah, the only thing, Dave, that I would add to that is, you know, these KPIs and the way that we worked with the Ascend team really drives accountability and drives a sort of performance-based culture. What we did is we sat down as we went from unit to unit and across the different plants, and we're developing these dashboards, we sat down with their stakeholder teams ahead of time to really vet, is this what they needed? Is this what they thought was important? And so the dashboards were reflective of the KPIs that were meaningful to them, so they weren't just sort of an arbitrary thing. And that level of involvement ahead of time and kind of helped us evolve the solution as well over time, drives that engagement and accountability.
Okay. All right. Thank you, Derek and Terry. You know, one of the things that kind of came out of this, and here's a question, is asking about workflow, and that's been touched on, of course, you know, through the discussion here of Visual Factory. Terry, can you speak to how important workflow is at Ascend as a result or as a goal of the Visual Factory and what its main advantages were? And also, I guess, Derek, if you can speak in general about the advantages of workflow based on your experience. So, Terry?
I think on workflow, as we've discussed, the e-logbook is very important. Operators really like that. We're getting more input than we did on paper. So the workflow is used to create that. The workflow is used for the daily instructions. Again, that is something that the engineers can use, or specialists, to input data into the system and provide information to the operators in electronic form. That makes them, as Derek mentioned before, is very accountable. They have to click on it and note that they have read and understood the instructions. Plus, the data in the daily instruction is sucked into the visual factory. Whatever the targets or new limits or something is going to be running differently that night or that weekend, all those things get sucked into the visual factory so that the red or the green are very appropriate. So I think the workflow, I'll just mention that it can also do alerts. It can send emails. It can do, I think it can even do texts and things, and do pop-ups, alerts, a lot of different things. Some things we've used, some things we haven't used yet. Plus, it can actually go through a whole troubleshooting. We've actually worked with one unit to do a regeneration procedure on workflow, whereas it will interact with the operator as to are these permissives met to go to the next step, something that is a quality or something that's not really in a DCS system that's not easily done there, but this can interact with the operator with using the intelligence that's programmed in there to actually lead them to a regeneration consistently, plus it records how it was done, so if there's a question in the future they could go back and find out what step might have been short-circuited or such.
Derek, anything to add in general about the advantages of having workflow?
Yeah, so the Skelta BPM solution is a very robust, mature solution. Ascend is using it to standardize and institutionalize certain actions and activities that they have going on around their e-logbook and shift reports and instructions. There really is a lot of opportunity for workflow at Ascend, and there's ongoing discussions around other ways that they can utilize that. One of the real interesting things about Ascend is, and why I think they've been so successful with this Visual Factory project, is they're constantly looking at new ways where they can apply technology and get a better understanding of their business. And this really has been a journey. It's not just been a sort of an individual project that once it's implemented, everyone goes along their way. They've really taken the solutions and are very creative about how that can be used within the enterprise. So that's been great to see.
Okay, thanks, Derek. This next question is asking about the best practice culture at Ascend. Terry, can you speak to this in terms of how Visual Factory affected this? Was there any, I guess, difference in the best practice culture at the company, say, before and after the installation of this?
I think with Ascend, we have something called A2E, or Ascend to Excellence, and something that it's modeled after Six Sigma. And this really is a great part of that. And if you know what Six Sigma is, that's DMAIC, define, measure, analyze, improve, control. And with that whole part of that culture that we're trying to bring to people's thinking, there's a lot of times that we'll do a project, and probably most of you on the webinar will understand this, that we'll go all this work, an engineer or specialist, someone will do a project. It'll be great. But then that person moves on to something else, and all of a sudden, after a while, the benefits tend to dwindle. That C, or control, is left out. And we really see Visual Factory as something that will control our process, control those improvements we've made so that they don't go into disrepair. So we see that as a very good benefit there of that. And say on best practice, I think we are trying to get there. We're obviously not have the best practices of everybody, but this is a great part of it. People see it. Operators see that we're trying to do something new. We're trying to use handhelds or tablets out in the field. That's something that they had not done before. It's a major change. They see that we're investing in them, and they see that we do the Visual Factory, the dashboards and such. It's something that they see that helps them. So as a culture, it helps them understand that we all want to move together to improve our systems.
And this is Derek, one quick comment there as well is one of the things that I've seen that I think is real powerful is you have folks at all different levels within Ascend who are using the Visual Factory solution. So that really sends a message to everyone that there's real value in using that, and there's a lot of opportunity there.
I'll make one comment to follow up on that we haven't made, that it's very important. We can take any tool out there. You can take intelligence, workflow, we can take IntelaTrac, and it's a tool. It's a tool. But if we as engineers, managers, supervisors don't embrace it, if we don't support it and encourage the use of it properly, if we go out and management by walking around, by asking people, how is this working, and why is this red, and why is there an alert here? And the operators and the folks need to understand that the whole company, is interested and ask questions, and we all get involved in this, and they see that, and it really helps them out. We had a story several years ago. We had a very kind of a crude dashboard. One of the supervisors put essentially a TV on the board. This is probably almost 10 years ago, and we put on there the BTUs per pound, a very gross KPI, and the engineers and that supervisor would go around and ask the operators, why are you doing well, or why aren't you doing well? Why are you above this number? Why are you below the number? All of a sudden, that tuned their reticular activating system to narrow in on energy is important to us. Why aren't we doing well? They would, and before the people would come to the control room, they would start thinking about, well, why are we doing well, or why aren't we? And we get that mindset to think about efficiency, think about why we're doing it. And the one dashboard wasn't sophisticated, but it was something that management really did embrace. So all that's to say that if you take all these great things that Schneider has, if you throw it out there as a tool and you walk away from it, your results are not going to be as good as they would.
Okay. Now, at another point in your presentation, Terry, you were talking about standardization and consolidation as streamlining as a part of the process for Visual Factory. Can you talk about what you achieved, with regard to that specifically, standardization and consolidation, how that helped?
I think I'll go back to the kind of example of one unit. We had so many different operators, and they would all look at different things. They would look at their DCS system, and one might look at, this flow into the system. They look at material balance to see if something might have been plugging up. Another person would look at some temperatures in the reactor. Someone else would look at maybe overhead flow rate and temperature combination. So we would try to streamline what they were looking at so we all could look at the same thing very efficiently. So if someone's looking at a trend to make sure that the ratio of this flow to that flow is within the right bounds, if it's starting to go up, he'd have to look at that monitor. He'd have to look at that IP21 or our historian trend to gather that. Well, here with the Visual Factory, we program that explicitly, and we could have either an arrow on there, or we could explicitly say this is now red if you're going up at a certain rate. So we would combine the different disparate items, the concerns that operators had, into one area, and you could have operator Joe, Mary, and Frank, their different ideas all in one place, and they could kind of share with each other through the Visual Factory. So I think we tried to standardize based on the best knowledge from the best operators and specialists, training coordinators, people like that, into one place where here's where they go. And the same thing with our IntelaTrac. With the IntelaTrac, we had limits. A lot of operators would go out there, particularly younger ones, newer ones, and would not know what the limit was. They just blindly write down a pressure, blindly write down a temperature. All of a sudden, wow, we've standardized. We have something that we can hang our hat on. Just a quick story. We had a air compressor in our Decatur plant. And the operators, they programmed it properly. We had good limits in. The operator went out, did his round. He typed in a pressure, I think it was 40 PSI from the lube oil system, and had alert. The IntelaTrac, the mobile device, said alert, pressure too high. He didn't know, and it just said, put in a work order, contact supervision. We could put in notifications right there on the handheld device. So that went to the maintenance department, and they looked at it and said, well, why is this high? We're not sure. Let's go to reliability folks. They went to reliability folks and said, well, is this range real? Is this really the right range? Should it really be 40 should be normal? And they said, no, 40 is out of range. So they went back to the compressor. They took a sample of the oil, sent it off, and found out that during some maintenance activities, someone had put the wrong oil in that compressor. It was too heavy a weight oil, and at some point, that would have caused the gearbox to crater and would have cost us $30,000 plus unexpected downtime. And all that because we standardized the rounds as to what people were looking at.
Interesting. Yes, there's some definite direct value out of that in just one case example there. So, speaking of that, case examples like that, during your presentation, Terry, when we were touching on the field workforce use with IntelaTrac, you said you had some stories. If there was time, you might be able to share one of those. You think you could share one of those with us about that related to the field workforce use with IntelaTrac?
Sure. One of our in our pilot, we had a really good participation and such, and we would go out there with our unit training coordinator, and just walk out and say, what did operators supposed to do? I mean, we had their log sheet. I mean, the log sheet was probably 15 years old, hadn't been updated and changed. So we tried to go through and say what needs to be changed, what needs to be stricken, what needs to be added. So we went through and he went through and said, well, we have all these vertical pumps, or cooling towers. And operators are, quote, supposed to, that's one of those key words. You hear that word, that should set a little light off in your mind. They're supposed to look at the access port on the motor to make sure the motor heater circuit is pulled in. And what that means is that those large vertical motors had a little 110-volt circuit inside the motor that would be on if the motor was off to keep the motor warm and dry. So when you hit the start button, it wouldn't go to ground and all of a sudden it short out. So it turns out that we programmed that explicitly. It wasn't written down anywhere, but it was one of those things that they were, quote, supposed to do. So we programmed that if the motor was down or the pump was down, the question would be asked, are the motor heater circuits pulled in for that pump? So it would remind them to open the access port, and if the circuits were not pulled in, then it would allow them to put a work order in, or notification, or contact the high voltage shop to get it fixed. And the previous year to what we started, they had 9 events. They call blue flash events, 480 volts to ground. And it was apparently quite a memorable event, but maybe not as memorable to remember to do it all the time, but to check. But that cost us $165,000 that year. From that time, this was about 4 years ago, from that time to now, we have not had a single event from that motor heater circuit not being pulled in. So we've saved $165,000 year after year after year of improvement, reliability improvement, by not having that issue. Just because we programmed with IntelaTrac, very simple, check what you're supposed to check when the right conditions exist.
Yeah, that kind of savings adds up quick, that's for sure. Absolutely. All right. We've got another question in here that's just come across, and this one might be better for Derek, but we'll open up for Terry if he has something to add too. This one is looking at your experience with this solution at Send. Would such a similar solution, how do you think it would work in different industries that probably have less process control parameters than, say, a Send does, such as like a steel or a metals plant? Can you speak to how this sort of solution might work there as well, Derek?
Yeah, I think it would be a great fit, right? The intelligence tool is, can handle all sorts of different data sources. So it doesn't just have to be process data or historian data. It might be MES data. It might be homegrown applications where there's data that exists. But we know today that many of our customers struggle with. They have all sorts of data, but it's tough to bring it all into one place. It's tough to provide context around that information and make that data meaningful. Intelligence does a great job of doing that, so I think it would be a good fit in those types of industries and those types of environments. and really give people one place to go to have more insight into their operations, how they're performing, where there's opportunity to improve their performance.
All right. Well, thank you very much, Derek. All right. Well, that looks like we're coming in on the home stretch here on time, so we'll go ahead and conclude today's webinar. So thank you, Terry, and thank you, Derek, and thank you all out there who have joined us for this webinar. For more information, please visit the website shown here.